Now let's begin by making a triangle. Just any old triangle will do. Let's come up here this way, just for the fun of it. And we'll come across there like that. And let's talk about our triangle in here. Let's call this one A and B. Where am I going to put that B? That gets to be a bit of a problem, doesn't it? Let's put it over here. And C. And let's number these angles so we can talk about them individually. This is angle number 1, angle number 2, angle number 3. How's that? What I'm wondering is there any relationship between these three angles on the inside of the triangle? And in order to investigate that, would you believe I'm going to draw a line through this point B up here that is parallel to my line on the bottom down there? And if you will remember, if I want these lines to be parallel, then I have to get these corresponding angles here to be equal. So I'm going to get an angle up here that is equal to angle 3, and then we'll have our corresponding angles equal. Let's get the compass out, and we'll draw our arc. There, that looks good. Here. And we'll copy that arc up here. And then we'll measure it and see how big it is. Just from right there to right about there. That's pretty close. Let's take that. We'll come up here and we'll make it the same. So our corresponding angles will be equal. If I draw a line through here, it should be parallel to the AC at the bottom down here. What do you think? Looks pretty good. Looks pretty good. Alrighty. Well, did you notice something here? I've got a vertical angle here. So this angle here, across here, angle 4, is going to be congruent to angle 2 because the vertical angles are congruent. So let me just make a note of that. Angle 2 is congruent to angle 4. And we made this angle the same as that one, so let's call this one angle 5 up here. And angle 3 is congruent to angle 5. Because we made them that way. These are the corresponding angles that were equal. That made those parallel. And these are equal to each other. Now, isn't that interesting? Isn't that interesting? Look at this. I got another pair of vertical angles here. Let's call this one 6 and this one 7. Don't you think? Isn't that fascinating? 6 and 7 are congruent too. Angle 6 is congruent to angle 7. Fascinating. I wonder what we can do with that. Well, look, these lines are parallel. So that means our corresponding angles are equal, and angle 6 and angle 1 are corresponding angles, so they're going to be equal to each other. Also, we've got equal angles everywhere. We're just all over the place. Angle 1 is congruent to angle 6. They're corresponding angles, both in the upper left-hand corner of the intersection. Isn't that fascinating? And this one here, let's call that angle 8, that's going to be the same as angle 5. Since that's the same as angle 3, then those are all the same. And my gosh, we got all sorts of things that are equal. I wonder what we can make out of this. Well, let's see. Angle 6, 4, and 5 together go halfway around the circle. They make a straight angle. So the measure of angle 6 plus the measure of angle 4 plus the measure of angle 5 must equal 180 degrees. How about that? They're a nice straight line. It makes 180 degrees. Well, let's see here now. What can we do with that? Angle 6 is the same as angle 1. They're corresponding angles. So I can substitute angle 1 for angle 6. Angle 4 is the same as angle 2. So in place of angle 4, I can put in angle 2. And then angle 5 was the same as angle 3. They're corresponding angles, so I can take angle 5 out and put angle 3 in its place. And lo and behold, we have shown that the three angles of a triangle must add up to, you got it, 180 degrees, the same as a straight line. Now, isn't that amazing?